So let's get started. I actually sort of don't have any slides because I was going to live code most of the stuff I wanted to sort of get across. So two of the things I'm going to be talking about is a sort of very hip and trendy piece of tech that's about 70 years old, sort of by now, sort of functional state machines. You may have heard it in sort of uni, and it's very, it's sort of been a part of computer science forever. There's still parts of sort of software development that sort of use them sort of regularly and or all the time, but like general purpose software development has basically forgotten about them for the past couple of decades. But they're slowly sort of making a comeback, which is sort of fun and interesting. So I've been sort of using them for sort of the last couple of sort of years. And sort of recently I was sort of thinking about sort of DDD when we're talking about some domain-driven designs, and aggregates or sort of aggregate roots. And then sort of I realized, like, what would it feel like if we, instead of using sort of like a more object-oriented sort of way of implementing, what would happen if we sort of use finite state machines sort of instead? And that's been sort of a interesting sort of exploration. And so that's basically what we're going to be sort of doing today. Is quick refresher, aggregate roots, sort of what are they, what makes them special, and then we'll just dive into sort of finite state machines to get a feel for what they are, and then we'll have a discussion about, would this actually work, right? What would it sort of look like? So to sort of start off with, in sort of contrast to the sort of previous completely not technical talk, a very much sort of technical talk sort of for now. Yeah, I know, it's mine. Probably should come back. So the one thing about aggregate roots that sort of makes them special is the sort of the definition of sort of basically, so what they are is sort of encompass sort of anything that needs to be transactional sort of consistency, right? So if you need two things to be sort of true at the same time, or only one can be true, that's sort of what you want to have sort of in the same sort of aggregate root in your domain model. So a lot of what you're doing there is protecting sort of invariance. If you're fancy and sort of want to use expensive words, invariance is a good one to sort of throw around. But basically what we mean by that is sort of different sort of representations of the same thing. So one of the things is, for example, an order, right? You can only cancel an order if you haven't paid yet, right? After you've paid, you need to refund the order, right? So those are two different things, different states that this sort of particular object can be in, and you have your aggregate root to sort of protect and make sure that everything is always in a consistent state. Yeah, and that's where things get interesting, and that's where I want to have a chat about state and modeling state, because that's a large part of what finite state machines help you do, right? Now, finite state machines are incredibly simple. A finite state machine is just a function. It's a function that takes as input the current state and some input, and then returns the new state. Right? It's completely stateless in that you pass in your state and you return to state. Right? So is this big enough, by the way? Big enough for here? How about the live stream? Can we give a thumbs up if that's readable?
Yep, perfect.
Cool. So, state. Now, let's do a trick question. By the way, I'm using TypeScript here. This is completely independent of sort of language or sort of anything, right? I'm not using very sort of advanced things. This is just to talk about the concepts of modeling. Yep. So, quick question. Is this a good way to model a light? Right? And I'm not sure if sort of are people doing on the live stream. Lee says, no, it is not. Right? And of course, this is a terrible sort of idea to model a light, because you can get in, you can now model a state that is invalid, right? Unless you can find a box big enough for my sort of namesake to put the light in, where you don't know whether it's on or off. But obviously a light can't be on and off at the same time. Yep. So terrible way to model a light. Now, what happens if we want to model a traffic light? And green. Is this a good way to model a traffic light?
I think it depends on the country you're in. Because in Australia, this might be better as an enum, but in I think America, I think some European countries, you can have orange and red at the same time, and sort of
Sure.
like this, right?
Sure.
Don't want to be picky, but maybe
No. I like, obviously I know, but even if that's the case, right? That we're in one of those countries where red and orange can be on at the same time. Is this a good way to model a traffic light? Yep. Where's my, do I have a chat? Where's chat? There's chat. Yeah, exactly. So what Lee says is, I'm not sure if it was for this one or the other one. This is still a terrible way to model a traffic light, because even if red and orange have to be on at the same time, can red, orange, and green be on at the same time? Right? So you can still model a traffic light in a way that is invalid, right? So this, for example, is orange or green or red orange or pulsating orange, right? These are all valid states that a traffic light can be in, right? Now, let's take this one step further, right? And let's go to a T-junction, right? And to sort of refresh everyone's memory, this is what a T-junction looks like. But what we're doing is we're going to make this as an even simpler T-junction. There's just one sort of set of traffic lights for every side, right? So one, like south is green, and you can go left or right, and everything else is red, right? So there's no independent or like right. You can left but not right, and keep it super, super simple. How would we go about modeling that? Right. Is this a, are we doing sort of this? We're going to start with west and east. Is this how we're going to model our T-junction? Any thoughts?
Same issue with the previous one.
It's exactly the same issue. It's exactly the same issue we had with the previous one. And so what are some of those? So what are some of those states that this can be in? Right, shout them out, type them.
So based on your example you mentioned before, like a basic would be that like if one of them is green, the other two are red. That's like the basic constraint, just for the simplified T-junction.
Sure,
Maybe.
but how do you, yeah?
Are we concerned with all the corrections at intersection?
No, there's just one sort of circle for any direction, right? So there's no separate lefts or rights or straights and sort of lefts. It's just one sort of road goes at a time to all directions. Yeah. So if you want to make your example a bit more specific.
So I guess the issue we're trying to get around here is how do we sort of, in the simplest possible way, represent the three physical traffic lights, but also encode the constraints on the states of the traffic lights. Is that broadly speaking what we're trying to talk about?
Yeah.
And if I recall how you explained it when you introduced this example, you said just as a simple constraint, you can only have one traffic light. If one traffic light is green, the other two must be red in this simplified T-junction.
Yeah.
Right. Unfortunately, like doing the JavaScript really, I have no elegant way of how to implement it. Right?
Yeah. So like, what we sort of can do is let's say like west is green, right? Which means that the other two obviously are red, right? So now I have all the information that I want. There's different ways to model this, by the way, and I'm taking a really simplified. I wouldn't necessarily do it this particular way, but this is just a good introduction to get your head around like models and states more than anything else, right? I'm not trying to teach you TypeScript. So West Green, what's another one?
Each one of those are your three sets, right? Like if you just say which one is green, and there must be some.
Okay. Yep. So East Green, South Green. What else do we have?
Combination of like all red, maybe.
All red. Yeah. You were going to say something? Oh, I thought you were going to. Yeah.
It's just a combination of all the ballots.
All the
ballot states.
Yeah. I'm just trying to get I'm trying to figure out what those ballot states are. Yep. So if like, that's the all red, right? Where all of them are red.
Is west green, west by south red.
Yes. Yeah. Exactly.
Yeah.
So you were saying before, like only one of them can be green at any time.
You just need the transition, right?
I'm still missing.
Well, I'm
yeah.
missing orange.
I'm missing orange still. So west orange, east orange, and south orange.
The assumption is that when any of the lights is orange, one light is orange, the others are still red.
Yes,
You know, kind of
Exactly.
Orange.
exactly. Yeah. Like it definitely, when we're saying this, it definitely implies that the other two are red, right? Now, the other thing we can do, and I think you just mentioned it sort of there, is not only do we now have all of our states, right, for Australia, right, in other countries, you might do a red and orange in between sort of as well for all of the three different ones. So not only do we have all of the states, what we also have is, what we also can do is all of our transitions, right? So if we go from west green, what other states can we go to from west green? Yeah, we can only go to west orange. Where can we go from west orange? We can only go to all red, right? And obviously, this is the same for all of them. Now, where can we go from all red? Yes. So this is west green or east green or south green. Yeah. Does this make sense? Yeah. Cool.
It makes sense. Maybe picky.
Yeah.
Is there a specific reason why, given that say South Orange always goes to all red, is this just a formatting thing we haven't thought through? Because for me, if I'm thinking this through, given that South Orange always goes to all red, would I be coding this so South Green, South Orange, new line, South Orange, all red, or would you sort of try and take lines of implication that you can't branch from and sort of make them one logical kind of unit in your function, in your state machine? I know it's a slightly stylistic choice, but I'm just wondering whether we've deliberately laid it out in its full entirety just because it's an explanation, or if there's some actual deeper reason.
So if I was going to model this out like properly,
Yeah.
I still would have these, like all of these same states, almost certainly. I would have to play around with it a bit to see what I would like actually do with. But I would probably still have separate states for like a west green or a like and a south green.
Yeah.
Right? Just to like get a feel for it.
Yeah.
So I would absolutely start out that way.
Okay.
Right? And unless like we would get to like tens of different states, I would try to see like how I could sort of probably model that differently. But one of the extremely powerful things about finite state machines in particular is that it is super straightforward and super readable. So I try to avoid any and all magic, like when coding these sort of finite state machines. Yeah.
I mean, this would almost call for having a state machine inside of a state machine.
Oh
Like,
yeah.
If you see orange, then it always has to go to red, right? Like something like this.
Yeah. Like
You could do.
you can, yeah. Like, and that's, but that wouldn't necessarily be my first implementation.
Yeah, I understand.
Yeah. Does that make sense? I might end up there. but I certainly wouldn't start out there. So here we have all of our state transitions, right? I'm going to take that question in a sec. So here we have all of the state transitions. But can anyone tell me what else we have here? Yeah, which is like basically our state transitions, right? What do we have here? All of our test cases. This is everything you want to test, right? Does my transition from west green to west orange go right? Does it go from west orange to all red? Right? This is all the stuff you wanna test.
Okay, I mean, maybe this is an advanced model, but I'm proposing, but how do you stop it going from west green to west orange to west red? West green, west orange to all red, then back to west green, to west orange, and then permanent loop of west only being green or orange, and the rest of them being starred with any access to. Yeah.
Well, yeah, sort of. We're now very much talking implementation.
Well, is that like a requirement of your design? Because that would be a natural requirement if you design a junction, that you wouldn't want any one road to only be on.
Yes, that could very well be. Yeah, and that's like we're probably going to need like more information if we want to satisfy those requirements, like in our state.
But we're not going to do that right.
We're not going to.
Okay.
We'll see sort of how far we get with implementing it. I don't think we usually don't get there. But when I've done this, when I've written like a proper implementation of this, I keep track of like how many ticks ago were they red, were they green, right? So that you can sort of in your finite state machine, if you go from red, you can go to the longest one that hasn't been green the longest, right? For example.
Okay.
Or you could take in other data where you go, oh, how many cars are at a particular road, right? And use that to switch on. But you're correct, we do not have enough information in our current states to prevent sort of transitions.
Okay.
Yep, good catch. So yeah, we had a question here in chat. Do we really need the colors at a T-junction? For me, the colors would be a technical manifestation of the traffic light controlling everything. I would rather use west, drive, halt, and so on. This is a question I occasionally get sort of as well. You're pretty, so it's correct that this is an implementation detail, but in this particular case, like it becomes much more readable with the colors, and for me that's more important than doing like drive versus green. Does that make sense, Adrian? Yeah, you're also like Luke also says, like colors are the language of the domain. That's also like a good point, and probably why I prefer it anyway. It's because yeah, in this particular case, it's very much it is part of that domain or traffic lights. But in general, like you're right, Adrian. Like you don't necessarily want to talk about sort of implementation details and bring that into your modeling. But in this particular case, I think the colors are much easier to understand than drive and halt and because what are you going to do for orange? Like maybe stop if you feel like it. It gets really harder to understand. And now, what you can do in those sort of finite state machines is go, if it's green, west green, return west orange, right? And those are sort of super simple, easy to explain sort of function, right? It becomes a really easy to explain function to, again, not just other sort of technical sort of people, but also very much sort of like your sort of non-technical sort of members. One of those things that we're trying to do when we're doing DDD, right? Like, how do you get that collaboration with people, with domain experts and sort of other people involved in the development of this particular piece of code? Because the other thing is, once we're sort of like talking about sort of testing, what would you have to like mock out to test this? Anyone has a guess what I would have to mock? Nothing. Absolutely zero. The only thing you have in here is actual sort of logic of your sort of business domain. That's the only thing you have in here. So it's super easy to test, it's super easy to read, and it's easy to explain. If you keep things sort of as straightforward as it can be, right? So back to those sort of aggregate roots, right? What we are looking for in aggregate roots is that transactional consistency, right? That if this is on, this is off. Right? One of the challenges with a lot of the object-oriented sort of way that we're modeling these aggregates is that the sort of shape of your object often changes over time. Right? I have an order that isn't paid, it's paid, and it's shipped. Right? Like the amount of and the type of information on these three different states of an object is very different. Right? So modeling that in OO is hard to do because you can't change your class like after a method call. Right? If you're a particular class, that's it, you're done. And so that makes it hard to sort of have these sort of transitions in time often and model them in a way where you do not end up with what we call this anemic sort of domain model, right? Where we have a unpaid order class and we have a paid order class and we have a shipped order class. And then if you want to sort of do it sort of another way, we very quickly sort of get into these services where we now have a domain service that does all the thing, but now we have all of our logic and all of our like other services sort of injected in that same piece of code. And so where I've been going sort of lately in some of the stuff that I've been working on sort of recently in some side projects is using finite state machines as that sort of service layer where you send either events or commands that will grab this, put it in one of those sort of state machines, gets the result back, and sort of get an object back that it then sort of saves. Right?
So that's the advantage of this sort of pattern, right? Is that if you don't trust yourself to set the attributes in such a way that the attributes are potentially inconsistent with each other for your class or the state that you're sending away, and say, well, I'm going to say I'm going to use my state machine or whatever abstraction I need. Say, I trust you. You're going to be responsible for effectively resetting the attributes on my behalf, and and then you have some sort of guarantee that when you get it back, or you trust the service enough so that when you receive it back, you know that the attributes are going to have that consistency. In a certain sense. So I mean, like in this example, it's kind of clear you're calling a function, and the example is described. You said, yeah, I sent it off to a service or something. It does the manipulation for me. I send it back.
Yeah, but what I can get back are so I don't trust any of my code to distinguish between like valid and invalid representations.
Yeah.
Right. The only thing you can do is model valid things. Right. That's one of the sort of powerful things that this sort of pattern allows you to do much easier than with sort of object-oriented sort of modeling.
Yeah.
Is so if we're talking about like an order. Right, we have what is it? Unpaid order. We have a paid order, and we have a ship order. Right, and all of these can be returned by and sort of when we're talking about these types, like the paid order obviously has some kind of payment information attached to it, right? That the unpaid order doesn't. So I don't have an order class where the payment information is optional, right? I have the an unpaid order has no payment information. A paid order has to have payment information. Does that difference make sense, right? So
Yeah, I agree with you. So for me, like my initial instant reaction when I see your example here, and I think it's, by the way, excellent that you're checking the chat. They probably have good ideas as well, right?
yeah,
But for me, like, I mean, this seems kind of weird to do paid unpaid shift order. I don't know TypeScript, but the way I write an order Python, the way I would do it is I'd say, well, listen, I know that there's some operation I might need to do on the order, such as payment, right? Set the payment attribute is paid. Right, for example, and then I'd write then a custom setter or getter for that class.
Yeah.
So when I go to access the attribute, I run my validation logic inside of the class to say, like, is the payment information there? Is it not empty? Is it valid? Is this a valid credit card? I don't know, whatever you want me to do. But then again, if you then have a big jungle of getters and setters and validation logic in your uber big class, maybe you potentially introduce inconsistencies through the back door, and perhaps in this case, a state machine would be a more intuitive way of modeling this out.
Yeah. So my point more is certainly around the because these sort of types sort of are like these types are like defined, right? And I can sort of look at it, which means I can't have a bug in my setter, right? because like a type system doesn't allow me to model this in a way that will ever be invalid. Right?
Yeah.
That's sort of like, I don't know how sort of Python's sort of type system has sort of evolved over the past, well, decade, to be fair. But
right, like it's so the example I was using is attribute access, setting an attribute or retrieving an attribute, and then you can sort of get it to do checks.
Yeah.
Or whenever you call it, whenever you set it, you can just put arbitrary code in there that automatically validates things.
Yeah. But sort of like this particular sort of way, and TypeScript is probably a bit more, or sort of any sort of like stronger type language is probably like it makes a bit more sense to do it that particular way than something like a Python.
Yeah.
But like when you're talking about like Java, you can think about this being different interfaces, for example.
Yeah.
I got a question.
Yeah.
I mean, if this is different types, your order is going to be in a database somewhere. Like the order is not something that just lives ethereally on some process. It's going to be saved. How would you load different types? Like you're going to have to serialize the database row, or you're going to have multiple rows. You're going to have like unpaid order rows, or an unpaid order table, paid order table, ship order table, model list. Whereas you know, if you would just have the order class with an attribute, it would just be a table, paid or not.
That's a great question. Just repeating the question just in case people didn't get it. It's like, how do you model this in a relational database? Is what you're saying, right?
You could do it with no SQL, but
Yeah, like to be like, yeah. So a lot of what I do these days is a very much sort of unstructured sort of databases where I use the so like where if I do use relational databases, it's mostly for like indexes. But even if I was going to do this in a relational database, I would still have one order table. And then sort of different ways of saving them. But I would still have one table for all of these because you still want to be able to do a query over all of your orders.
The purpose of these states here affects what attributes you contain order as the order goes through its life cycle.
Yeah. Now, in this. Yeah. Yeah. Although it's also possible that you get into sort of things where like much more changes than just like it's not like this is very much like additive, right? Where you keep adding things. Occasionally you get into situations where like stuff isn't present here. Like we remove things sort of at a later step because we don't need it anymore. But yeah, it's very much not just, it's the same thing, it's just in a different state, which means different things can happen to it in a particular state. Yeah.
How do you take into consideration in the system, the state machine? How would you approach how would you take?
How, what do you mean?
So say for instance, like 30 seconds or it transitions back or whatever. So for instance,
Oh, okay.
state, or perhaps maybe there's a combination of like you can only get from East green to East orange, but it has to be after 30 seconds.
Yeah, so I would definitely model that as an external sort of thing, so that you get if time is important. So I'm building one of the things I'm building is a finite state machine runtime where you can return more than just a state. but also side effects and things like timers. But yeah, if you're using sort of vanilla state machines, yeah, you definitely want to have like external to the state machine, sort of give another input, in this case, after 30 seconds, right? Where we stay green for 30, we stay orange for 30 seconds. So after I've got an orange state back, I'm going to set a timer for 30 minutes and call the state machine again with a timer action, and that will then give me an on all red instead of back.
And with history,
History is one of those things where you can keep it if you want.
so say for instance, like maybe the pattern of like, say for instance, you went orange, red for the past 2 cycles, and maybe the third cycle you want to do something. Maybe it's something different. So with that, in terms of historical,
Yeah, it's just part of your state. Yeah, like if history is important to you, you just model it. That's what I did. Now, unfortunately, I realized that my example was on my other laptop, not this laptop that died. But yeah, like I was describing before, in that example, what I do is I keep track of how long ago one was green, right? So I had it was my sort of T junction. Oh, I had that up here, didn't I? T junction is right. State name is right, West Green, for example, right, or West Orange. And then we would have like last green for West was, and then right. Does that make sense? Yeah. So this is basically the history that I need to make these decisions on. And so if I go, so if the state is all red, I can go and check, right? I can go to state, like sort of last green. Figure out which one is the highest, and then sort of return that. Yeah. Does that make sense?
yeah.
Perfect. All right. Any other questions about finite state machines, roots?
So where you got the transition from red to green?
Yep.
That's an opportunity to have other state machine sides to cycle between like west, east.
Yeah. Yeah, you definitely can nest sort of finite state machines. If that's what we're looking for. Yeah, it's definitely possible.
That way you actually when you've got your transition, you've got three choices.
Yeah.
Right there, I would imagine we have a juice function that on the state machine that passing to the state juice function will maintain in this direction.
Yeah. So the suggestion was like do you have another state machine to do the choosing between which one to go green? In this particular case, because the logic is so small, I would inline it in this particular state machine. But you're absolutely correct. Like, if that logic becomes like a lot more involved, I might break that out, or if it's something that you want to reuse, like over multiple state machines, for example, I would definitely like put that into its own state machine and call that exactly. But for something relatively simple and straightforward, I would just put it in the same sort of state machine. Again, for me, the only thing that matters in software development is how easy it is to read and to understand. So whatever is the easiest to read and understand what it's doing.
How would you, obviously a state machine is a very good way of modeling your domain, but it is obviously not can't solve all use cases. What's the guiding principle as to like when you would use a state machine and when you wouldn't? Because there's a lot of upfront cost, and any further modification or any extendability, let's say for instance a new rule, a new business rule, requires the whole modification of the entire system. And that integrity could be impacted because a lot of engineers, people coming and go, and some have to.
So the question goes around like when to use when to use state machines and like where not to, basically. Yeah. So when it comes to modeling logic and modeling state, sort of programming logic and modeling state, I haven't found anything that's easier to understand and than sort of state machines, because they are almost completely devoid of anything that does not have to do with logic, right? Let me see if I can. Oh, it's not in presentations. It's in projects. Micro labs. So here's a finite state machine I wrote in sort of anger. And this uses a library so basically I wrote the code traditionally, right? And I needed to fix a bug, looked at the code and couldn't like look myself in a mirror and sort of go, no, this thing does exactly the right thing, right? Now, this is an open source library used by some really big companies with a few sort of tens of billions of requests a month. So I figured I wanted to get more comfortable with that it was actually doing the right thing. So the only thing I could do was model it out into a state machine. Right now, this is a tracing library, and again, we can start like this is a library that built state machines for you. But yeah, we can go and like we're not started. If we're in progress, this is what's in progress. This is what a complete trace is. This is sort of exporting and done, right? These are our sort of states. Here are our sort of transitions from not started to in progress, from in progress to in progress, from in progress to trace complete, from trace complete to exporting, or from trace complete straight to done, and then exporting and sort of done exporting, right? And here's the actions that we define, and here's our sort of handlers. And like, and certainly again, like what I did is all of these handlers are in their own set of methods. But here is how that sort of goes, right? Like start and export, blah, blah, blah. There's a promise that sort of goes in there, and here's what we return if we're exporting. This is what returns if we're not exporting, right? So all of these are really simple, relatively easy to understand sort of things, even to people who are new to the code base. So yeah, like when it comes to the changeability of something, I much prefer state machines over almost anything else.
The ease of understandability typically is quite subjective. I think that's fair to say, right?
Yes, I know, but yeah, go on.
Well, in the non-trivial example that you presented, I know of developers who can't be able to handle it because it's too concise, essentially. I mean, some developers I know will be able to handle it. I'm okay with it because I've been functional programming for a while. But for many people, this is quite tricky to understand. Like it's.
You mean this?
Yeah, I mean, that's a lot of things in a single call that. What happens if there's an issue, right? Like what happens if in state exporting, export state exporting, like how would I debug this? I get some stack trace that's like 5, 6 functions deep into another function.
So this only sort of creates the state machine. So you don't actually see any of this sort of in a stack trace, right? So what you'll see is a new trace, a new span, an and span, or a start export function.
Okay.
Right. And like I said before, I could not understand. I literally could not sort of look myself in the mirror and go like, no, this thing works, right? It's sure to work. And I wrote it, right? The fact that you're now able to go like, yeah, I guess I get what's going on is already a hell of a lot better than what it was, right?
I thought I got what was going on, then I relooked at it. But if I was a beginning programmer to add a state to this, so how would I do it? Like, if I can progress from, directly from in progress just complete to exporting, how would I come along there?
From in progress to done?
Yeah. In progress to done and tris complete to done. If you already have that, okay. What about if exporting fails and you want to restart? So you want to go back to in progress.
Well, you would sort of stay in exporting then, right? Because we're not in progress anymore. The in progress is we're in progress of gathering the data. So you would sort of go here from exporting. We can stay in exporting.
Okay, and action handler. Okay, what I need an action handler, like I might build export parts. So if it goes and transition.
And like right now, you would sort of your export done. You would probably need a new action that is a sort of export failed. And then you write an action handler. Why are you bitching at me? Yeah, but and again, like this is sort of library. Oh no, it's of course not. Like it's Exporting. Oh, of course, I need to have a promise in there as well. Can I do that? See, this is, so what it actually sort of was like, my exporting state is incorrect because,
That's okay, I was just.
but like this is how you would sort of go about that. Yeah.
I get it. I'm just not sure every code.
No, but like this is like it's a new way of thinking about things. Like obviously that's going to take some bit of time.
It's a different paradigm.
But it is a different paradigm.
What's holding it back? I mean, what's stopping it from like being adopted?
It's and to say like it's new, it's not actually new because it was invented in the 50s. But like it's new to a lot of us again. The mechanism, it's the most important one. Not enough people know about it. Thanks. Yeah, let's see if we have some on the chat. TS checked FSM. Of course, I can just TS checked FSM. That's really. Thank you for the link. I'm going to definitely have a look at that one. We really appreciate it. Right, we're going to be kicked out of here. Oh, geez. We have another hour. Oh my God.
So this library here.
Yep.
I imagine naturally a graphing library or something like that would show how a state machine works quite well.
Mm-hmm. Yeah. Yeah.
Behind this library, is there some sort of a visualization tool that shows the finite state machines?
No. No, the only thing it gives you, the only thing it gives you is exactly what I was showing before, right? Where
I actually use, I think it was JavaScript, but
Xstate is a popular finite state library.
It does
Yeah.
have a visualization.
Yeah. There's a cool startup, like the people behind it, Stately AI, and they allow you to like just give you an editor where you sort of visually make your state diagrams that you can then basically go give me the Xstate that you can then run.
Something like that where you can actually visualize what's in the system. That is what we so they can piece together.
Yes, but what so yes, if there is a direct link between the diagram and the code, right? Otherwise, you're in the same, like it's just a spec, right? Which may or may not be actually implemented in the code. But yeah, I wouldn't, like if you have a state diagram in, I don't know, TL draw, and something else in your code, that's not very useful, right? And that's why I prefer to explain the code than it is to show them a diagram which may or may not be true. But yeah, there's definitely ways where you can get a lot closer to state diagram and code with things like Xstate.
How far would you take it? Like, would you build an entire program application using this system, like the way you designed? Or would it just be a small, precise problem that you can isolate the messy parts of?
So the thing I'm currently building has finite state machines for every bit of non-trivial logic, right? And that's basically, if it's more than an if statement or two, it's a finite state machine.
There be any drawbacks? Like, was there? Surely there's a cost to it.
No, so it depends on like the level that you're going for, right? So this particular one, it's a more formal definition, right? Because there's type for everything, and I use do the transitions and then the actions and then the action handlers, and this takes a bit more time, not a ton of time, but it does. So I wouldn't do this for necessarily for everything, but a quick little state machine with 3 cases and like 3 types in it, and just return things to it straight away. It's super easy to do. It's super testable if you want to, but often it's so clear from what you're doing that, yeah, you don't even need to.
It's because I've actually tested like using XState as part of like front end. Say for instance, like inputs form. That's something that you can actually. It's a problem that you can isolate.
Yep.
Needs to find.
Oh, sorry. I get your question now. Sorry. Like, I would never have like one state machine for everything, right? That's like, there lies madness,
Yeah.
right? Because what you're going to do is you're going to explode your states, right? Because if you ever find yourself typing "and" in a type name, you've probably screwed up somewhere, right? Well, not just screwed up, but you probably can split them out into 2, right? And that like massively reduces your the amount of states, right? So, for example, if you look at traffic light versus T-junction, right? The traffic light has, like, certainly, as we said, we were going to ignore those, like, has 3 states, right? Where our T-junction has 3, 6, 7 states, right? So if you can model them as sort of 3 separate traffic lights, you should totally do that, because it's a hell of a lot easier to understand. Like, the reason you can't do that with the T-junction is because you want to restrict. Like, so you can't sort of model them as separate traffic lights, because they need to, like, one influences the other, right? So that's why you do a T-junction, and you end up with more states that way. But that's like part of the complexity of the problem, right? It requires a slightly bigger finite state. But yeah, I would never use one finite state machine to rule them all, right? So this is just in the spans processor. That's it. Yeah. All right. Yeah, and this is Luke sort of comes with a comment. It might not be easier for new developers, but it's a solid alternative to looking through hundreds of lines of code to determine all the state transitions. And that's exactly what it is. Very often we now have logic in things like API handlers or event handlers on the front end. And that makes it really hard to change or even understand, because the logic is separated out into many different places. that's it. I'm going to hang out in the chat for a bit longer, and sort of around here. But I need to grab myself a beer because I've been talking for way too long. So feel free to. I'm going to stay in the chat if you have any questions. Sort of let me know. But thank you. Did you want to close out?